What's going on, everybody? I had a couple of questions come in about how to diagnose electrical circuits. So we're going to kind of start at the beginning. I'm going to run through and show you how a basic circuit works, explain some of the nomenclature and power flow. We will cover how to use your DMM. It's important that you know how to use that before you try to start using some of the other tools such as power probes. It can get really dangerous really fast and start costing you a lot of money. So just to get started, the basics of a series circuit, what it is a a series of loads that share the constant power source, but it goes from one load to the next load to the next load. So the common things that you're going to see when you're looking at your electrical diagrams is you'll see symbols and definitions, and they'll give you a basic breakdown of where the circuit starts and where the circuit ends. So in a series circuit, what we're going to do is we're going to read from left to right for this specific example. We always start at our battery. Our battery is going to be our source voltage. When we come across, we've got to have a load protection, then we're going to have a switch, then we'll have our load, and then you'll see the ground circuit. And when you see these common points, it doesn't necessarily mean that it comes straight back to the battery directly. You know, a lot of these grounds on your vehicles will be chassis grounds, body grounds, but they all tie back to the battery's ground. So to look at what our basic components are, what we need for a circuit to work is we need our power, we need our ground, we need our load, our load protection, and our switch. And then these are the common symbols that you'll see. Now the only one that's really going to vary is your load, because what I'm using for this example is a simple light bulb. So like I said, as you're going through it, you'll see where each piece kind of plugs into the circuit. It's important that you can read this, because when you start to power flow a circuit, if you're not sure what you're looking at or you don't know how to read a schematic, you're going to just be poking and prodding around in a bunch of wires, because once you start getting into the actual automotive side of doing this, it's not all laid out all pretty. You're going to have just big conglomerations of wires. You're going to have to be able to read colors, gauges. You're going to have to be able to power flow an entire circuit with more than just simply what you see on the board here. So another thing I want to cover with you guys is how to use your DMMs. Now everybody's is a little different. If you've been around long enough, you'll understand the importance of having a good DMM. Mine is a fluke. If you guys have been around long enough, you'll understand the importance of having a good DMM. One that you understand, that you can use, that you can read, because if you don't know how to use the equipment that you're trying to diagnose with, well, you don't know what you're reading. And you're never going to get the right answer, you're never going to find out what the problem is. So I'm going to take you off the stand and show you this exact same circuit I built on a board. If you guys can see that a little better there. So like I said, there's two ways to actually read schematics, and they're either going to be from left to right or from top to bottom. And once you've done it a couple of times, you'll be able to just look at the schematic and understand which way the power flow goes. So there's that. And now here's the same circuit, just built on a board. So we've got our power source. We've got our load protection, which is our fuse. We've got our load, which is that light. And then coming all the way back, that's our ground circuit. The only thing I didn't put in is a switch, because I didn't have any simple switches, so I will act as the switch. Here's our 12 volts coming from our source. And if the entire circuit is wired correctly, circuit works. So like I was saying, you need to be able to understand how to power flow, but in order to do that, you have to understand how to use your DMM. So what I'm going to do is give you a brief overview on how to kind of use your DMM and how to use it to power flow. So if you recognize that you have a problem with an electrical circuit, let's just say, any switch that you flip and you used to have some lights come on and now they don't, you need to be able to understand where the power starts, how it gets to the load, how the load uses it, and what it sends back to the battery. So some things you need to understand, some terminology you need to understand is DC voltage, ohms, and AC voltage. Now AC voltage, we're not going to touch super heavy on today because you really shouldn't be seeing that in most of the electrical circuits. Now it is prominent in other areas and we'll get to that at a later date. Like I said, this is all just basic videos on how to. So if we want to see why some of our components aren't working, you need to start by setting your DMM to DC voltage, okay? So we will set our DMM to DC voltage, and what you should see in the corner, depending on what style you have, is you'll see a symbol that pops up that says DC voltage. I like to start by making sure we actually have power to the circuit. So I will take my red lead from my DMM and go right to the positive side on the battery. And then I'll take my black lead, it's going to be blue because I can't find my black marker. And we're going to run that all the way over to our negative side. Now, without the vehicle running, this is called a static voltage reading. And what you want to see there is at least 12.5 volts. So let's say we're good. And then on our DMM, it says 12.5 volts. That means I know I have power in my system. Now for the rest of this, because the battery ground is one of the best grounds, it is the best ground, you can leave your black DMM lead there, and now we're going to power flow. So as power goes through a circuit, when you're looking at it on a diagram, like I said, it's either going to go left to right or top to bottom. In this case, we're going to go left to right. So if I know I have voltage starting right here from my source, I'm going to take my red DMM lead and I'm going to start tracing my circuit. So then I'll come over here and I'll check power coming into that fuse. If we still read 12.5 volts, we know we've got power still going through it. Then I'll come over and I'll check the other side of that fuse. If we still have 12.5 volts, that means we've got power flowing through that fuse is not blown. The next thing I go, it's right down the line. Check power at the switch with the switch open. That means you should still see 12.5 volts with the switch open where the hot line comes in. Now if we leave the switch open and we test the other point, with the switch open we should see 0 voltage there. And if we do, then you can go ahead and close the switch. And there again, now you should see 12.5 volts. And then you're going to come down the line and you're going to check where power comes into your load. Again, if we still see 12.5 volts, we're good. If we don't see 12.5 volts, that means between our switch and where it comes into our load, we've got a problem in there. Now as you come to the other side of the load, and this is where you need to have your expectations set. If everything is working as it should, when you come over and test the other side of the load, you should see next to no voltage. If you see voltage on the ground side, that's bad, because that means we're going to have high resistance over here, causing some of the voltage needing to be consumed to get everything back to ground. So, reset all this shit. That's essentially what power flowing a circuit is. You start at the beginning and you trace it all the way through. So if you have your expectations set, we know this circuit works. So we know we should see voltage at both sides of the fuse. We should see source voltage at our switch when it's open on the power coming into the switch. And then we should see it again when we actually close the switch. And then once we close the switch, our light turns on, and that means everything's functioning. So I will take you off the stand again, and I will show it to you on the board. Expectations versus reality here. So here we're going to set up the DMM. Like I said, we're looking for DC voltage. In my top corner, you see DC voltage. Here's our power source. So I've got my ground lead attached to the negative side of the battery. And then we'll come over and get a static reading. And what we see is 12.5 volts. So that means we've got power for the system. So, like I said, because I don't have a switch set up, what we're seeing is from our source voltage coming up to our switch, there's our 12.5 volts. So connect that, and now we can make sure, obviously the light works, so we know we've got voltage going everywhere, but to show you how it goes. So now we'll test here, and this is our load protection device. We've got 12.5 volts coming into it. We've got 12.5 volts coming out of it, which is also the lead coming into our actual load. So we know we have 12 volts coming in. Now this is where we don't want to see excessive voltage, because this is our ground side of the circuit. So that means, obviously, because the light turned on, the load is consuming the voltage, which is exactly what you want to see. Alright, now that I've kind of shown you how to shoot or troubleshoot a circuit, now let's know. Alright, now that I've shown you what a good circuit looks like and how to do your basic power flow tests, what I'll show you is some common failures. So, again, we need to have our expectations set. So what we'll do is we'll keep it set up the same way. We'll keep our black lead on ground, and we'll create a fault in the system. So what we'll do is we're going to close the switch. So the switch is closed, but we're going to open the ground. So to set your expectations, you turn your lights on, but they didn't come on. So if you're going to start power flowing again, same concept. You start at the beginning, you've got your source voltage there. You come over, you got your source voltage here. You got the switch closed, So we know we should see source voltage all the way up to our load. And then our last test that will go is on the back side of the load. So what I explained in the last video was that if we have source voltage coming all the way up to our load and our load comes on, we want to see no voltage on the ground circuit. So in this scenario, what we'll do is we'll actually open up the ground and I'll show you what you're going to see and what it means when you see something like that. So we'll start again by setting our DMM to DC voltage. We'll keep our black lead on the battery ground side. And then we're going to come through and test all this again. So here we've got our switch closed. We've got 12.5 volts coming in. We go to the other side of our load protection device. We've got 12.5 volts coming in, which is the same connection for our actual load. Now this is where you need to pay attention to what you're seeing. So because our load did not illuminate, and we know we have 12 volts coming into it, when we come to the back side, we wanted to see next to no voltage. We're seeing almost 11, a little over 11. Same reading. So because we don't have a path back to ground, the load isn't consuming anything. So when you see source voltage on the ground side of the circuit, you know you have an open. So let's say you go through and you find it all again. You find the open and you repair it. We've just given ourselves a path back to ground. So we'll do a quick version here. We got 12.5 volts coming in. Come to the ground side. And next to nothing. So that's just basic troubleshooting. Other common things you might see, and this is why being able to power flow a circuit is important. You need to have the expectations set before you start going through and gathering your readings, because if you don't, you could very well just overlook the problem and spend twice as long trying to fix a problem. So if we start here again, we know we have our 12.5 volts coming in. Then we go to our load protection device, like our fuse, and taking it out is going to simulate a blown fuse. We know we should see 12.5, but again, we're seeing millivolts. So that would tell us that our problem is between here and here. So everything you're doing as you're going through this stuff, it's having a systematic approach and understanding how to use your tools, but also, just as importantly, having your expectations set and knowing what they mean when they're not met. So today we kind of covered the basics of the electrical circuit, specifically a series circuit. Now they do get more complicated. You've got parallel circuits, you've got series parallel circuits, and I can go more into depth on how these circuits function, how to use the different tools. But like I said, the biggest thing is that you're comfortable with the basic tools. Because if you don't know how to use that, and you start getting into some of our more expensive tools like our power probes. Power probes are unbelievably awesome tools if you know how to use them. Problem is the majority of people don't understand exactly what they're doing. So a tool like this can actually send source voltage through a circuit. And if you send it the wrong way, you just fried a computer. But with everything that we kind of went over today, you should have a basic understanding of what to expect when you walk up to a car and how to start developing your own procedure as far as where you want to start and how you want it to end, where you want to end. So if you guys have any questions, these are some of my first videos, but if you guys have any questions or if you feel I went too fast or skipped over anything, leave me a comment, let me know what you think, and I can tailor all these videos from there. So I appreciate you guys tuning in and listening. I hope you learned something, and I'll talk to you guys next time.